Understanding Big Data, a comprehensive guide. What is big data? Big data refers to the vast volumes of data generated at high velocity from various sources, which are too large or complex for traditional data processing systems to handle efficiently. Big data encompasses structured, semi-structured, and unstructured data, offering valuable insights when processed and analyzed correctly. Underlying technology. The underlying technology of big data includes 1. Data storage and management. Distributed file systems. Examples include Hadoop Distributed File System, HDFS, and Google File System, GFS, which store large datasets across multiple machines. NoSQL databases, such as MongoDB, Cassandra, and HBase, designed for unstructured or semi-structured data. 2. Data processing. Batch processing. Systems like Apache Hadoop use MapReduce to process large datasets in parallel across a distributed network. Stream processing. Tools like Apache Kafka and Apache Storm allow real-time data processing. 3. Data analysis and visualization. Data analytics tools, Apache Spark, Apache Flink, and Dask provide in-memory processing capabilities. Visualization tools, Tableau, Power BI, and D3JS help in visualizing data insights. 4. Cloud computing. Cloud platforms such as AWS, Google Cloud, and Microsoft Azure provide scalable infrastructure and services for big data storage and processing. Associated concepts. Volume, the sheer amount of data generated. Velocity, the speed at which data is generated and processed. Variety, the different types of data, structured, semi-structured, unstructured. Veracity, the quality and accuracy of data. Value, the insights and actionable information derived from data. What is Hadoop? Hadoop is an open-source framework developed by the Apache Software Foundation that allows for the distributed processing of large datasets across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. Significance of Hadoop. 1. Scalability. Hadoop can easily scale from a single server to thousands of machines, each offering local computation and storage. 2. Cost-effectiveness. It uses commodity hardware, making it cost-effective compared to traditional enterprise storage. 3. Flexibility. Capable of storing and processing a wide variety of data formats. 4. Fault tolerance. Data and application processing are protected against hardware failure. 5. High availability. Data is stored across multiple nodes, ensuring high availability and reliability. Application of big data in real-life use cases. 1. Healthcare. Predictive analytics to forecast disease outbreaks and patient outcomes. Personalized medicine by analyzing genetic data and medical history. 2. Retail. Customer behavior analysis to optimize product placement and inventory management. Personalized marketing and recommendation systems. 3. Finance. Fraud detection by analyzing transaction patterns and anomalies. Risk management and credit scoring using large datasets of financial transactions. 4. Transportation, traffic management, and route optimization using real-time data from GPS and sensors. Predictive maintenance for vehicles and infrastructure. 5. Social media, sentiment analysis to gauge public opinion on various topics. Targeted advertising and content recommendation. Famous applications of big data. 1. Google uses big data for search algorithms, ad targeting, and optimizing user experience. 2. Amazon employs big data for recommendation engines, inventory management, and pricing strategies. 3. Netflix analyzes viewing patterns to recommend content and produce original shows based on viewer preferences. 4. Facebook utilizes big data for social network analysis, targeted advertising, and content personalization. 5. Uber leverages big data for dynamic pricing, route optimization, and demand forecasting. In essence, big data involves managing and analyzing large data sets to uncover patterns, trends, and insights that traditional data processing systems cannot handle. It relies on technologies like distributed file systems, NoSQL databases, and advanced analytics tools. Big data finds applications across various industries, transforming how businesses operate and make decisions by providing deeper insights and more accurate predictions. Hadoop plays a critical role in big data infrastructure, offering scalability, flexibility, and cost-effectiveness essential for handling massive datasets efficiently.